Why isn't it working? I just checked the console and everything seems to be looking fine. Where exactly the issue? Where is the bug? I can't even see it. I can't even find it. If you have ever been in this situation, sprinkling console.log everywhere in your code just to figure out what's wrong, trust me, you are not alone. Often, as a developer, when you're fixing a bug, we get confused whether I have to change something, we have to remove something, or I have to add more functionalities, more line of code to make it work, isn't it? Like coding, debugging is also an art. We have plenty of tools given to us to use them to make the debugging effective. However, we love and like console.log, isn't it? Hardly we give any attention to the dev tools, but we tend to do everything that is really not required. For example, running the same code again and again, expecting that it will work magically. Or let's go ahead and search for it. Let's see how others have fixed it. I don't find it. Let's search more. But the most necessary thing is to use breakpoint. You make sure that you go most organic way to attack a bug, to kill that bug, and make sure that you fix the issue at the end of the day. Believe me, guys, programming is not just about coding. Once you are doing programming along with coding, you also will be spending a lot of time debugging. To me, programming is 60% debugging. Yes, you will be spending that much time finding out what the issue is for the line of code that you will be adding or the line of code that you want to remove or edit. You can count my words on it. So if you're just relying on console.log to figure out what's the issue in your code, believe me guys, there is a better way of doing it. A way that makes debugging easy, fun, and even powerful. That's exactly what we are diving in today. Let's learn to debug JavaScript like a pro using Chrome DevTools and VS Code. When I say Chrome DevTools, and if you are a user of Firefox or Edge or Safari, don't worry about it. The things that I'm going to show using Chrome DevTools are also available equivalent way in your browser DevTools as well. So you will be able to try them out. So let's start using them. Let's win our bugs. So what's the goal for this lesson? We have done an introduction. Next, we'll be talking about what is debugging. We will look into an application that will be using to debug and learn debugging. We'll of course talk about the famous console.log. We will then get into DevTools and we'll see an overview of DevTools. Among everything in the DevTools, the place where we'll be focusing more today is called the source panel. Then we'll learn how to set up debug points, how to debug code, what is conditional breakpoint, how to debug handlers like click handlers, key press handlers, all these things, how to debug on DOM changes. Now, DOM is something that we have not learned as part of 40 days of JavaScript yet. That's coming next, but it's not a problem. I can still explain and show you like how to debug DOM changes. Then we're going to learn about the debugger handle. Again, something as a utility that we can try out for our debugging purpose. How about the debugging scope, how to observe call stack while debugging, how to watch variable expression, how to edit and save things on the runtime. We'll learn about Workspace, what it is and why it is useful. Then we'll switch the gear towards VS Code from Chrome DevTools. We'll learn the similar debugging thing but with VS Code. So that you don't have to leave VS Code at all. You probably don't have to go to your Chrome DevTools, but there will be a place where VS Code may not be useful. You have to use Chrome DevTools. And after that, I'm going to end this video with a few debugging tips that over the years I have gathered, and I feel that that's going to help you a lot. Unlike other videos or other sessions, this video won't have any proper task. Only task that you will have after this is start doing everything that you learn from this particular video. Try out all this thing on a sample application so that you get hands-on on each of these things that we'll be learning today. After this video, I want you to be very confident in terms of using DevTools. So your task is to be confident and try out things till you feel that you are a confident developer to use tools for your debugging purpose. I hope this video helps you a lot and you like it. And if that is the case, please post a like, post your comment, and don't forget to subscribe to tapaScript. Let's get started. Let's get started with the definition of debugging. What is debugging? When you are building an application using your code, the programming logic, the problem solving mentality, everything, you are trying to implement an use case or a feature for the end customer. Now, while doing that, we expect the feature will meet all the requirements that your customers or the end users are looking for. But often it happens that while developing the application, we might miss out a few things. It could be because of skill issue, or lack of understanding of requirement, lack of understanding of technology, or maybe any other environmental issues that is sometimes not in our control. Now, the thing that gets introduced and change the behavior of the application, the way that is supposed to be versus what it is right now, and the mismatch, that's what we call as bug. So if there is an issue or the bug in our code, the reverse of that would be debugging, right? It means that we have to find the bug and eliminate the bug, eliminate the issue from our code, from our feature, so that it meets the end expectation of a customer or the end user. Of course, these bugs or the issues are not intentional, right? We don't intentionally put those issues in our code. It happens. It happens due to several reasons just now I mentioned. But we need to know that what are the ways we can track them at a later point in time and then fix it back. The process of tracking them, tracking the issue, tracking the bug is called debugging. And then you do the removal of the bug once you debug and find it. That particular phase is called fixing. So we are going to learn a lot about the debugging technique today. We will see what are the tools that we can use to find out the bug and then how to eliminate them. For that purpose, I have developed an application, a very simple application which you are seeing on the screen, a very simple make a wish application where you can come and say your name is Tapas Adhikari and I wish for teaching JavaScript to million of developers, right? Now, if I make a wish on this application, what I'm getting at is like there is a greeting message which says, "Hey, Tapas Adhikari, your wish in a N may come true. I have wished something with lot of interest and love, but what I get back as a greeting message that my wish itself I cannot read. My wish is to teach JavaScript to millions of developers, but it's showing that not a number. So that means there is a expectation mismatch of what I am expecting this particular application to do or to behave versus what it is behaving. So as we found a bug, an issue over here, the next step would be to figure out and find what is the issue, and that's what we'll be doing as part of the debugging. And after that, we will fix this issue as well towards the end of this video, and so that we can actually print the wish that I'm looking for. So I hope the background of debugging is quite clear to you. The code you're seeing on your screen is the code of that wish, make a wish application. What we're going to get down now, the importance of console.log in our life. We love console.log developers. I personally like console.log a lot. That's probably one of the most used way to figure out what's going wrong in your code. And I don't think necessarily the console.log is bad. In fact, I think they are great because at any point in time, going to my browser DevTools, going to the console tab, I can figure out in the sequence like what would have happened with my code. That's why in this code also, I have posted a bunch of console.log. I've created a function called logger where you can pass any text and it just do a console.log along with saying that it is a logger function. That's it. And I have called this logger function, in the function which is actually printing the wish. So if I run this program, the one that I just now showed, and I wished for something, I want to see like what would have got printed in the console.log. For that purpose, I want to bring the DevTools out, and most of you might be knowing that how to get the DevTools out and work on it. The shortcut that works is called F12 on your keyboard, or you can right click on your web page and say inspect. This inspect option must be there on all the browsers. On some browsers, it is the last option. On other browsers, it could be somewhere else, but on the context menu itself. So you click on inspect. This opens up a DevTools for you. This is what is developer tools. Straight away, if I go in the console tab, the tab you see over here, that's going to give me all the console messages. Console messages could be of different types. It can be an information message like this, or it can be a warning message like this, or if there is an error, it can be an error message. On Chrome DevTools especially, these are segregated now, but if you want to see all the messages, you can just click here. You will be able to see all the messages irrespective of their type. So if I go to info message, I am seeing those two info messages coming from my code. One is saying I am a logger function. The other one is saying, hey, Tapas Adhikari, your wish NAN again may come true. So it means the wish that is getting prepared after I click on this button, I am also logging this. And it also says very clearly at which line this particular log is generating from. So it is getting generated from the index.js file, line number 17. I can go to my source code and try to figure out, hey, line number 17, this log is coming. So that means this log is being called from somewhere. Where it is getting called from? It's getting called from here. So this message is having some problem. Of course, I'm seeing that. But it's not giving me enough to identify what exactly going wrong with my code. What is that portion of the code that is creating the problem such that I am not able to see the wish listed and the greeting message that I'm getting after clicking on the button. The console.log probably helpful, as the name suggests, for logging purposes. What is logging? You want to know what exactly going on with the functionality, with the function, with the code execution flow or the error flow. You want to check back at a later point in time, looking into the series of action, reading into the series of action, identify what would have gone wrong. And this is really important. The logging is really important, especially for your customer scenario. Once you deliver your product to an end customer, you don't generally deliver the source code. The source code will be with you, will be with your company. The same source code will be compiled, built, and it will be created as a deployed artifact that will be hosted somewhere or will be given to your customer to run. What your customer gets at the end of the day is like a binary, not the source code. Now once they run that on your browser and there is something wrong happen, how would you even figure out like where exactly the wrong thing happened? Because your customer is not going to give you back the source code to tell you, hey, at the line number 74 it broke. Or the customer is not going to sit with you to understand the source code and tell, hey, line number 74, that problem is there. That is where console.log is immensely useful if it is allowed for you to put certain error log wherever there is an erroneous condition happen, wherever there is an error problem happen, which you might not be able to catch it very evidently or show as a toast message on the UI, but still you might want to log on those situations. So it means that your customer now can open their browser, can go to their DevTools if you just guide them, can go to that console tab as we have seen, and if there is an error like the one that I'm seeing over here, like one error, they'll be able to see, hey, look like there is an error. A listener indicated an asynchronous response by returning true, blah, blah, blah happened. The customer may not even understand what exactly happened, but they can send you a screenshot of this. Looking into that, you can figure out, oh, look like index.html, this particular line, this error is happening now, is ringing some bell. I am understanding there is a problem. I look back to my source code, try to identify more, try to debug more to see what exactly the problem. So console.log could be a definitely great start and to figure out something that is happening in your customer environment. But the rest of the story, guys, is the usage of tools. That's why I'm going to introduce you to the dev tools, especially the sources tab. That's what we are going to spend most of our time in, understanding what it offers and how beautifully, what is a fun way you can actually debug your code with different options, different methodologies, different way of looking into your problem. So please learn this, practice it, and master it. You can open these dev tools in multiple different mode. If you look into the top right portion, there are three dots. You can click on these three dots and that's going to show you the dock side option. The dock side option shows you like where do you want to place this particular guy, this particular dev tools, so that it is easy for you to manage and debug. So the option that I opted for right now is in the providing the opening the dev tool at the right side. Because my UI is at the left side, it's easy for me to do side by side debugging. For some folks, it might be easy to do it at the bottom. So if you see now debugger is at the bottom, you can see the same thing over here, all the things, and can do your debugging, keeping the debugger at the bottom. This is also convenient for some people. For some people, I have seen that they feel convenient because it's at the right, and you can also do that if it works for you. And in many times when I am really doing intense debugging, I really know like where the problem could be, but still I'm not able to identify it. I go in a mode which is like no disturbing mode. That is this. I don't want to see the UI, actual UI. I'm more interested in the debugging the code, finding out the problem. So I go in this particular mode. This is my most preferred mode most of the time in with the real world problem solving. But as we are learning, I have to switch between the UI and the code. So better I run this in this particular mode. Now, along with sources, along with console, there is another tab is called elements, through which you can inspect each of the UI element with this particular handler. Once you click on this handler, click on any of the UI elements, this is going to select the corresponding element on the right side, and then you can see much details about it in the below pane. You can even control the styles of the element from this particular pane and can do a lot of stuff over here. Console, we have already spoken. You can see all the console logs segregated manner, especially in the Chrome DevTools. Source is what we are going to get a deep dive in. But let's quickly look into other possible tabs. One other important tab is called the network tab. And this is what I am going to teach you. Again, the debugging session version 2, when you go for asynchronous and synchronous module. In that module, there will be a lot of call that will be happening to the APIs, to REST endpoints, GraphQL endpoints, fetching the data, doing things. That's when we will see what happened on this particular tab, network tab, how to inspect and debug things from over here, and how to solve some of the critical problems with real world use cases. Apart from that, there are other tabs like performance tab, one of the most crucial tab to understand what is going on in your application from the performance point of view. Our last module in 40 days of JavaScript is where we are going to get a deep dive into this performance tab. But from that, there is memory, application, there is something called Lighthouse through which you can audit your entire application. You can figure out like what is going wrong, where exactly it is going wrong with the audit report, and try to see like what is the overall score of your application and try to fix it for a better usage. And then you have something called privacy and security, where mostly you can deal with the third party cookies, all those settings. In my opinion, learning DevTools may require another 10 days of DevTools kind of initiative. Let me know if you guys want to do that. I might plan that as well in future. But part of 40 days of JavaScript itself will be learning a lot about DevTools. Today is with the source panel. Chrome DevTools provides a lot of different tools to perform JavaScript debugging tasks, including DOM inspection, profiling, network calls inspection, what we have seen. As we are interested in the source tab or the source panel, this is what helps us debugging JavaScript. The source panel has got three primary sections. This left side section is called the file navigator section. This right side section is called the code editor section. And the section below is called the debugger section. These are the three sections and this is their name. File navigation or navigator section, code editor section, and the debugger section. All the files and the folders that you can refer for your application that you're running. There are possibilities that you might be seeing lot many other code than your application alone. All depends on what kind of browser extension you would have used and what are the other code that your application might be using and fetching. So based on that, you might see many other code. But for this Wish app, whatever the code that I have written for the JavaScript, HTML, CSS, in that the JavaScript code will be able to easily locate from this left side panel. And once we locate that, we'll be able to open that in the right side code editor. So let's do that. How can I do that? How can I open the file? You know that file name is index.js. So you can press something called Command P or Control P. Command P for Mac, for Windows keyboard, it will be Control P. So once you press Control P, this gives you a panel to type down the file name where you think the problem would be or you want to debug. So you do index.js and then you do enter. So this is opening up, as you see, the source file and the folder. The folder is day 16. Inside that, index.js, well, index.css, all are there, but I'm interested in JavaScript code debugging. So I've clicked on this index.js and this is opening up the code, enter code in the right side editor. Now, as I see the code, what I can do now, I can make myself ready for debugging. And to do that, we have to understand the concept of a breakpoint. So what is a breakpoint? A breakpoint is a point in your code where you want your code execution to be paused so that you can start looking into the things there or around it to identify what kind of problem your code might be having. Who sets the breakpoint? It is you as a developer will be doing that. When you are on the source pane or the source tab of the debugger tools, you can set a breakpoint on the editor section. So as we are dealing with this particular message and here the wish is not printing correctly, maybe I will put a debug point or the breakpoint somewhere here. Now to put that, you have to come to this leftmost column where you can see the line number and mouse over on the line number where you want to put the breakpoint and just click on it. The moment you click on it, this is going to set up a blue arrow for you. It means that on this particular line, your code execution will be paused so that it gives you an opportunity to look into what would have got wrong with your code. You can set as many debug points or as many breakpoints as you want, but you cannot set the debug point or the breakpoint on the empty line. You're able to see over here, line number 5, I'm not able to do. Now you may ask, like, why am I not able to put the debug point on line number 7, 8, 9, 10? Is only because line number 7, 8, 9, 10 belong to line number 6 only. This is the same expression which is been formatted between the line number 6 to 10. That's why you can put the debug point only at the beginning of the expression. So like that, you can put as many debug point or the breakpoint possible. But for our use case, let us put the breakpoint on the line number 4. Once you have the breakpoint decided, the next thing that you can do or you want to do is to run or the simulate your application's use case flow once more. What does the simulation means? You know your customer has faced an issue. The first thing after getting an issue you should do is called reproducing that issue. What is reproducing that issue means? What customers have told you about the steps. You will be performing the same steps with your application and try to see you are able to generate the issue yourself or not. In most of the cases you will be. If you can't, you will be looking for more steps from your customers or more information from your customers or the log. This is where the console.log is very important, or the log from the customer, so that you can start your investigation from there. But let's assume that your issue is reproducible. So you will be able to reproduce it, and before reproducing the issue, you have a guess, like, where exactly it can happen. In our application, a very small application, where I click on make a wish, and on click on the make a wish, this gets printed. So I have a print function and something wrong with the wish that I have put over here. So my best guess is saying this particular wish value probably wrong. So that's the reason I have put a breakpoint on the line number 4. And as I have put the breakpoint on the line number 4, the next logical thing I'll be doing, try to recreate the scenario so that when I now click on the make a wish button, my code execution pause over here and I can start taking a deeper look into the code to figure out what exactly happened. So let me click on make a wish. The moment I click on make a wish, I see the code execution has been halted over here. Now at this stage, as you won't be looking into the left side of the browser at all, you can expand it little more further. And are you seeing what is happening? The more I expand, the below panel automatically getting set at the right side, because it is going to give you more room for doing the debugging, for looking into this code, and can do things side by side. So this is another mode I like. The moment I'm getting into my debugging mode, I want to be either in this way or in the full screen way, where I can dock it out and just looking into it without disturbance mode. So here the breakpoint has hit, and that's what this orange color strip is saying. Now here few things for you to learn. Once you want to debug something, you have to learn different ways of debugging it. In our program, we mostly deal with functions. If you are a developer for a few years now, you can really validate this thought, like most of the cases you will be dealing with function. There will be a bunch of functions written in your source code file, and one function will be calling another function. One function could be passed as an argument to another function, and one function can return another function. So there are various ways that you will be dealing with function. Each of the functions gives a feature, part of a feature, or a functionality for your entire application. So if something broken, it must be broken in any of those functions that you have to figure out and you have to fix. That's the whole reason we have put this debug point. But now the point is, once I have put the debug point, the issue you may find on the line that you have put the debug point or the breakpoint on. But in most of the cases, it will happen that it is happening in the surrounding lines or the surrounding places. It may not be on the line number 4 itself. So it means that you have to now go in this paused or the debug mode step by step, one step at a time, one line at a time, to understand what exactly happening with your source. While doing that, you might have to get into some functions if your code is calling a function, to make sure that you're not only debugging your code line by line, you're also getting inside another function and try to figure out if there is something wrong in that function or not. It might also happen while debugging that particular inner function, you figure out, hey, there might not be anything wrong with this function. Let me just go out of it. I don't want to spend my time and energy to debug this inner function because I'm quite sure there won't be anything wrong with it. So you have to step out from that inner function. You have to come out. So you're saying you have to go line by line. You have to step in inside a function. You have to step out a function. Then you might also feel that, hey, boss, look like this line number 4 to line number 11, there is no problem. I just want to jump from this line number 4 to line number 11 directly. So you should be able to do that as well, because you don't want to go line by line to waste your time. Here it's just a matter of 4, 5, 6 lines, but it might happen that you have to jump from one line to the 100th line, skipping rest of the line in between, because those might not be relevant to the problem that your end users or you are facing, right? So this is what you will be facing in debugging, and that's where this DevTools is going to help you with all the options. At the right side pane over here, which is also visible when the screen is smaller at the bottom, like over here. Now the focus, let's put onto this, all these symbols, and let's try to understand what each of the symbol does. I'll start looking into it from the rightmost side. So when I mouse over on this right arrow, it says step F9. What does it mean? It means the action that I'm going to take is called step. And if you press the key F9, this is going to carry out that step operation for you. So first let's understand what is step operation. So this particular step option enables you to step through line by line of your JavaScript code. If there is a function call in between, the step through also gets inside that function, executes it, and then again line by line it goes, and then step out of the function. Let's take this as an example, right? Now you see here my debugging point is at the line number 4, and if I see down at the line number 11, I have a function, and inside this function I have not provided any other additional debugging point. So in this case, I will do this particular option, step option. I can click on it. The moment I click on it, you see it goes to the next line. If I click on it again, or if I press F9, right now I am pressing F9 from my keyboard, it gone to the next line again. Now if I press again, as per the definition of step, if there is a function, it will automatically get inside the function, and then it will execute the function again line by line. After its execution, it will come back and execute the other function from where it got into the previous function again line by line. So let's go through it. If I do this, I see now the control went inside the logger function, and then I can execute that line by line, and after the execution it come back to again line number 12, because the logger function execution is done. Now this particular step function or the step method is very useful when you are really not sure where the problem could be. You want to go through each of the functions along the way and try to figure out if there is a problem in any of the function, because you are really not having much clue, and you want to step into each of the line to figure out the things. So this is the first thing, what we call as step. The next option I want to talk about is called step over. You can see my mouse over here, the step over. When I'm mousing over on this, it says step over next function called F10. So step over is like step, but it has certain differences. What is that? This option again allows you to execute your line of code and the function without stepping in. So it will go step by step. Again, if I press on it, it will go to the next. If I press on it, it will go to the next. But if I press again, or if I press the F10 on my keyboard, now this is not going to go inside this logger function at all. We have seen in case of step or the F9 that from this point it was going inside this logger function, executing it again line by line, and then again coming out. In this case, if I go, it is just not going to go inside it unless I have a debug point over here. So let's do this without a debug point. Let's press it. You see, it just ignored going inside the logger, but it doesn't mean that the logger function didn't get executed. Please don't be misunderstood. The logger function got executed, but this particular operation doesn't go inside the logger function to take you through step by step. So when you use this, if you're sure that certain functions along the way may not cause this particular error or may not cause this particular issue, you might just want to skip them. This is the time you will be using F10, this particular methodology. Now you might be already getting right that in your code there could be certain functions, there could be 4 or 5 functions. Among that, maybe one function is what you kind of pinpoint that there could be a problem. But before going there, you also want to see from the outside what kind of data it carries before it gets inside that function. But all other function along the way, you are very sure that those are not going to cause the error. So somewhere you will be pressing F10 to step over, it means that you are not stepping inside those function. Somewhere you will be using the step F9 because now you are interested to get inside the function. So you will be using the combination of things. Sometime what will you do? You will be pressing a breakpoint like this inside a function. And then from over here, you want to directly jump into this particular breakpoint. That also possible. How? In this case, in this case, you go for the option called resume or jump. And the key shortcut for that is F8. This is the one. Either you press this or press F8. So if I press F8 on my keyboard right now, you saw that what happened. The control jumped from here to here, even without showing you going line by line over here. It didn't pause anywhere here. It just went to the next debugging point, next breakpoint, so that you can resume your debugging from here. So that's about this F8. We call it as resume or jump. Now there are two more options left. One is called step into and another is called step out. You can see this arrow is showing that is going inside, means it's like step into, and this is about step out. What does step into and step out does? Let's understand. You will use the step into or the F11 shortcut option to investigate a function in a greater depth. When you are stepping through using F9 or F10 and you have a feeling that, hey, look like this particular function is behaving or maybe behaving unexpectedly. Let me just step into it. So how I'll be doing it? Let me go ahead and start doing this step over F10, F10, F10. Now coming here, you were not doing F9 so far. So coming here, you feel like, hey, look like this logger function might be creating a problem. So at this stage, if you press F11, which is this one, step into, it is going to go inside this function. And if you want to come out at any point of time, so you can step out using Shift F11, so it will come out of this particular function. You getting the point? So again, to give you a revise or the overview, F9 or the step, it's about going through each line, and while going through each line, if it find a function, it will automatically go inside the function, execute and come back. Or step over, it executes the JavaScript code line by line, but if it finds a function, it is not going to get inside a function. It will execute and show you the executed outcome. We're going to see that. If you want to move from one breakpoint to another breakpoint, completely jump, go for F8. Now, if you're going by F10, but you figure out at a certain point of time that on this particular function I have to go inside, press F11, do the step into. While you are inside a function, you want to come out of it, do a Shift F11, come out, step out from that particular function. So these are the key combinations you have to remember and you have to master to debug your JavaScript code effectively, right? I hope you understand that. So take a task, create a table of these keys like F9, F10, F8, F11, and write the purpose at the right side so that you will never forget that, and put it somewhere in front of your eyes. If you're new to it, then you'll be accustomed by using it. All right. Apart from that, there are a few other things. For example, some point in time you are debugging, but you figure out, hey, look like I figured out the issue. I really don't have to debug it further. Let me just disable all the debugging, right? So to disable all the debugging, you have an option here at the right side. You see that deactivate breakpoints. Just click on this guy. You saw it's got deactivated. The blue color got changed. And now, even if you have a debug point over here, I'm just taking this out. And if I just do F10, see, it's just gone out. It is gone out of this index.js altogether, right? Along with that, there is another way that you can do. Do you see at the top, there is something called paused in debugger? You can also click on this particular blue to say resume. Once it's resume, in this case, the debugger itself will be over because there is no breakpoint that is activated. So this is how you do things. You manage things from here, all this panel, all these pointers to debug things step by step and to figure out what would have gone wrong. There are a couple of more ways you can set a breakpoint. So for whatever we learned, it was about setting the breakpoint directly on a particular line, but you can also set something called a conditional breakpoint. A conditional breakpoint in JavaScript debugging is a powerful tool. It will allow you to pause the execution of your code on a specific point, but only when a condition is met. So it means that hitting the breakpoint always and every single time is not required. You know, like under which condition your application might be failing. You can actually simulate and trigger that particular condition on this editor over here and your breakpoint is going to hit just that. I have seen that it happened with me many times when I debug a complex JavaScript application with a larger code base. A particular code logic or a particular function or a logic inside a function might get called again and again and again. Now, if you put a debug point over there, your debug point is going to hit again and again and again and again whenever the function is getting called. But you might want to hit the debug point only when it meets a condition. Let's see that. For example, this particular print method, whatever the time or for whatever the value over here, I press this make a wish button, any debug point over here will be hit, isn't it? It doesn't matter if it is for Tapas Adhikari, it will be hit, or if it is for John and I do a make a wish, this is going to hit again. But what if I am facing a problem such that this particular functionality is broken only with the name is John? I know. Now for all other names, I don't want to hit this debug point. That's the time I'll be going for this conditional breakpoint. So let's put a conditional debug point. To do that, you have to right click and select add conditional breakpoint. Click on add conditional breakpoint and here you can put a condition. Now let's put a condition like if the name is John, only in that case you pause the execution. You see over here now an orange color arrow comes compared to the blue color and there is a question mark also. This implies it's a conditional breakpoint. Now if you try for Tapas, do some wish, make a wish, nothing happened. You get this particular message over here also. Let's try for James, some wish, make a wish, nothing happened. Now let's change to John, John, and then make a wish. You see, you hit the debug point. So that's the whole point of it. Like based on a condition you're hitting, you know it might be a problem with this particular name John. Once you mouse over on this, you're able to see the value of it as well. So when it is John and I am interested in debugging right now, I was not interested in debugging in the other conditions as well. This is where the conditional debugging helps a lot. Once it hit the breakpoint with conditional breakpoint as well, the debugging methodology is just like before. You will be using these keys F8, F9, F10, F11, Shift 11 to step in, step out and all these operations. I hope it is clear to you. There are a few more interesting ways that you can set breakpoints. One way that I like is about the event listener breakpoints. You see this event listener breakpoints over here, this option, expand this one. This is going to show you all possible events on your web application. Let's say we pick up a keyboard event or a mouse event, whatever. Under mouse event, you will find like click event, double click event, etc. Like that on the keyboard event, you can find there are many keyboard events like key down, key up, key press, etc. Now you can select any of this event. So for example, I select a key up event. So it means you are not putting a breakpoint explicitly in any part of the code. Rather on the entire application, you want to debug anywhere you have a key up event. So if you have any inputs there, if there is a key up happening, means you are pressing a key, it means you are pressing a key, making it down and the key is getting up. In that particular event, this will be fired. So at a global level, you have made one explicit breakpoint. Okay. Now to see that, if I just do this guy, I have this text box and the text area, right? Over here, I just start typing W. You see what happened? It hit a debug point. It starts with a very, very initial level and it will show you the event that is captured over here is called a keyboard event, which is a key up event eventually. And then if you want, you can actually go ahead and go line by line, you can debug your thing. So this is another way that you can set up a breakpoint at a global level on the event handler. Let me show you one more way of setting breakpoints that I think you will love it. It's about setting a breakpoints at the DOM node. So DevTools is equally powerful when it comes to DOM inspection and debugging. You can set breakpoints to pause a code execution when something is added to the DOM, removed from the DOM, or changed in the DOM. How powerful it is. Now to do that, come to the Elements tab. This is where you can see the entire DOM structure, right? We are going to see a lot of things in the upcoming module in DOM. Now, let's see like how can you set a breakpoint even here to stop your code execution and debug further. That's really amazing things that I have learned and I use a lot. You remember when I fill up this particular form and say make a wish, I get a greeting message over here. That particular greeting message comes and sit inside this particular div. You see this div over here. I'm inspecting right now. I'm holding it right now, which is having an ID called output. and a class called content, and dynamically the content comment sits over here. You see, when I type something, I do a make a wish. Just see here on this div is got something. If I expand, it gets a span dynamically inserted over here. That's a message. That's a greeting message. So it means on DOM, dynamically, I'm able to add certain node, right? What is node? What is attribute? We're going to cover in the DOM module. But for now, I am adding an element on this particular DOM node. It means that I am modifying this DOM node by adding another new node to it. So when such thing happen, when such condition happen, when such changes happen in your application, you can conditionally add a debug point. How good it is. Your customer is clicking on a button, something you are supposed to show somewhere or want to hide somewhere. That is not happening. You can start the inspection from your DOM node itself to figure out why certain things are not happening. So let me demonstrate it with this example itself. To do that, I come back to this div again, where dynamically another node is getting added. I'll right click on it and you will find an option called break on. See here, break on, and it says break on subtree modification, attribute modification, node removal. It means that if someone is removing this node itself, div id itself, that means you break on this breakpoint. If some attribute is modified, some property of this particular node is modified, then you break on this breakpoint. If a subtree modification happen, it means that a node is getting added, a child node is getting added to this node, you break on this breakpoint. Now the subtree modification, this attribute modification, this node removal all happens programmatically, but you can break on each of these operations. That's the power of it. So in our case, we know there is a subtree modification happening. Whenever I'm clicking on make a wish, a new node is getting added inside that output div. So it's a subtree modification, right? So I will break on subtree modification. The moment I say subtree modification break, you see this particular gray circle over here. Now let me make a wish, London, and I make this wish. See, immediately it hit the debug point where I am inserting that particular node. See here, document.get element by id dot inner html equals to that span. That's the exact span is getting added. So if I execute this line with fn f10, and then probably I will go out of it using fn f8, and if I go to this element, I will see below this div this span has got added. As many times I click on it, that many times it will break on this particular one, because every time I am adding this node over here. If you want to come out of it, just click on this gray circle, come to break on, and uncheck this subtree modification. That's it. Then it won't break on this subtree modification at all. So I find this one also very classy, very cool way of debugging your code. You start with your HTML, then node inspection, and get into a JavaScript code to do further debugging. I hope you found it helpful as well. As you have learned all these different ways to hit the breakpoint, let us now do the real debugging. Okay, hit on make a wish. My debug point is hit. Excellent. So the thing that you are interested in right now is to debug and find out the value of each of the things that you are interested in and try to fix the problem that we have. What is the problem in hand, by the way? The problem in hand is, hello Tapas, your wish NaN may come true. Whereas I'm expecting, it says, hello Tapas, your wish a tour to London come true. This is showing NaN, right? So there might be some problem with my code. There is no problem with the name because name is actually showing correctly. So ideally, I won't be putting my debug point on name to start with. I'll be putting on wish or after wish, because I want to see what is the value of wish coming out, right? I'll take the debug point out from here. I'll put the debug point over here because I want to know what is the wish message coming out. Now, if you have seen my this code breaking or the code pausing is still at the line number 3 because that's where my debug point was. But I want to jump to this particular debug point. You know what is the key? It's called F8. So I'll press F8. I directly come to this line. So here a few things to look into. First of all, if I mouse over on an executed line, I will be able to see whatever the values set to those variables. So for example, if I want to know what is the value of name, if I mouse over on this, it says Tapas because that's the input that I have given over here. If I mouse over on wish, it will say R2 to London because that is what I have given over here. Now, if I do a message, it won't tell me anything because this particular line is not been executed yet. Once this line gets executed, then I'll get the value of the message. So if I execute this line, means if I do an F9, I came to this line. Now, if I do message, I'm saying, hello Tapas, your wish NaN may come true. It means that the problem had already happened. Here I got the wish correctly, a tour to London. Here I am getting the message says your wish in. That means there is definitely a problem in this line. Let's see what it is. If I see over here, it says again, message hello Tapas, your wish in. But name is saying Tapas. Wish is also saying a tour to London. That means still here also wish has printed correctly, but still the message is saying your wish in. That means mostly this is the line that is culprit. And what I see, if I look very closely over here, the value of wishes are to London, but there is an extra plus before this one. So I am interested, I'm curious. I have used this plus to concatenate the string, which you should not be. You will be using template literals, but let's assume that a developer, your one of your friend has done this and you are fixing this. So of course you are probably cursing that friend, saying that, hey, why have you used this plus to concatenate? If you want to concatenate, you will be using template literals. It's much more friendly and straightforward. Okay, fine, you have used it, but why is this extra plus? Now if I take this extra plus and then if I just mouse over it shows nn, so this is the culprit look like. This extra plus is the culprit. Now you want to figure out whether your that particular code change will work or not. You have not made any code changes into your source code yet, not on VS Code. So I told you that we can actually edit code in this editor. That's why it's called editor. So what I'm going to do before I run and execute this one, I doubt this particular plus would have caused this because it gives NaN. So I'm going to remove this plus. I'm going to save this guy using Control S. The moment I press Control S, it will rerun. And now I can actually go step by step, or I can directly go to F8 so that it will go to this particular line. Now I will do F9. Now see message. Hello Tapas, your wish want to go to Alaska may come true. So my problem is solved. I have debugged it and have fixed it also. Now I don't have to go inside this logger at all because I was only worried about this message fixing. I can just come out from here pressing F8, and then I will be able to see this message properly. Hello Tapas, your wish want to go to Alaska may come true. So my issue is solved. So you have seen like how before even I jumped into my code and fixing this one, I could fix this over here, and then you figured out like it has really fixed it. Now let's go to our code base, index.js. This is still having the problem, isn't it? Because I have only saved temporarily on the browser DevTools. Now I have not saved it coming here in the actual code. So I'll come now and save into the actual code. So this is to show you that you can edit, you can save the changes over here, and then once everything is working fine, you can take the change selectively and then put it back to your VS Code source code and then refresh it again to make sure that those are in sync, right? You're not running something from this browser DevTools alone. It is synced with your VS Code code changes as well. So I hope this is useful. Now there are a few more things are important for you to know. Once you hit a debug point, there are things that you can actually do on this pane. We have learned about scope, closure, all this thing, isn't it? So you can see the value of the scope, closure, all these things over here. So for example, right now I am inside this print function, inside the print function at the line number 6. So being here, if I ask you what will be the value of this, if there is a console.log this over here, you can easily tell the value of this will be window. Why? Because inside the function, the value of the this is window if you're not running in strict mode. Correct? Our script is not running in strict mode, so it will be window. So it's showing over here like local means this particular function scope. The this point to the window. Name is dfgfg, whatever I have put over here. The wish having some value. But the message value unavailable. Had I declared message with var, the value of the message would have been undefined. We have learned that in wasting. But as I have declared the message with const, once you declared with const and let, it will be created. The memory will be created, but it won't be initialized with undefined. That's why it says the value is unavailable because this particular line has not been executed. At this time, if you have a global variable or the global execution context, whatever it is, you can see all this value over here. Right now, it is just the window object at the global side, right? Nothing more than that. So as you progress, I'll go fn. Now I'll go inside this particular function as well. Now I'm inside the logger. Here again the scope is become what? This logger scope. The text is the parameter, that's value is over here. Apart from scope, you can also find there are a few other options, for example call stack. As we are inside this logger function and the logger function is called from the print function, print is defined in the global execution scope, which is getting triggered from the on click on this button, right? So the call stack is very well, you can see over here. If I expand call stack, you see I am in logger right now. The logger is called from print. Print is actually due to on click. So you can see this entire stack over here. That's amazing. Now, for some reason, if you don't want to rerun your application again, there is something found inside this particular function, but you don't want to rerun this application again. You want to just loop in this particular function to check what would have gone wrong again and again. For that purpose, you could right click on this call stack and say restart frame. Once you do restart frame, again, it will restart, but your debug point will be on this function itself. You don't have to again go back, fill up something, click and come back, because your attention right now only in this function, and you want to just restart this particular frame in the call stack to check again and again that what would have got wrong. Or you can also right click and say copy stack trace. Once you do copy stack trace, if I come to console for a moment to paste it, you see the stack trace over here. The logger line number this is called from print line number this. The print is called from day 16 line number 16. Amazing, isn't it? There are a few more things that I want to show you over here. So for example, there is something called watch. You can find an option called watch over here. Expand this and you can add any variables of your choice to watch. I have a variable called wish and I want to watch on this variable. When my code execution is paused, I don't want to mouse over on the wish again and again to figure out what is the value of wish. Rather, I want to add this to the watch mode. So for that, I'll click on this plus and I will add this wish and press enter. Now it says wish is not available, of course, because I am not running this application. Neither the application is in the paused mode. So now I have a debug point and I'll just hit this particular button over here, make a wish. My debug point has got hit. Do you see the value of wish got populated already? Now this particular line of code, line of number 6 to 10 has not been executed. Now, if I want, I can add as many. I will add message. It says message not available because message is not created yet, right? It's not something that created with var. Then it would have told undefined. It's with const, so it's not created. It's created but not initialized. Now, if I do F10, yes, now message got the value. I'm seeing the enter value over here. So this is how the watch is very helpful. There is another way that you can do. For that, click on this 3 dot at the top and click on show console drawer. The console drawer will be nothing but your console tab coming over here in the source tab itself, which is very, very powerful. You can see the console and the source together, which is very, very powerful. Now here you can add and watch for an expression as well. So for example, this eye icon, you can click and you can add any expression. So for example, I can add my wish is wish, and here I can add it like this, like a proper template literal, so that whenever wish has a value, I can check this entire expression over here itself. So you are not going to your source code again and again. You are not writing console.log again and again. You are in the debugging environment altogether where your entire source code is available. You are doing all possible things, taking help of all possible angles to figure out where the problem is. And once you figure out the problem, you can even try it out by editing it directly. I showed you there. And once you're satisfied that that fixed the problem, then you go back to your code and change the code. That's amazing, isn't it? So I hope it was great learning about putting the debug point, debugging the things out, figuring out how to fix the issue, finally fixing the issue, etc. There is one more way that without explicitly putting any debug point on your DevTools, you can still pause the execution. For the JavaScript provide you a way. The keyword for that you will be using is called debugger, debugger. This is the one. So wherever you put this debugger, you can put as many time as you want. Your code execution will be paused there. When the code is running on your browser, your code execution on the debugger tools will be paused over there. You don't have to explicitly put a debug point. So at the line number 11, I have put this one, right? So let's go back to DevTools. I can see this at the line number 11. Make a wish. You see, I don't have any debug point whatsoever. There is no breakpoints. Make a wish. You see, it hit on the debugger directly. Now, same process. You can check name, you can check wish. Your watch is working over here, your message will be working over here, your F8, F9, F10, F11, all will work over here. Only difference is you haven't explicitly put the breakpoint over here. Rather, in the code itself, you have put this debugger and through which you're hitting the debug point. Should you be doing this? I would say you can avoid it. You really don't have to do this as long as you're making use of the Chrome DevTools or the Firefox DevTools or the Edge DevTools, whatever the browser you are on. You can put the debug point over there and you can actually hit the debug point necessarily and execute your code. Please remember that if you are new to debugging, you're just getting started with debugging, you might be putting a lot of different breakpoints in different places. But the more experience that you gain over the period of time, you yourself will notice the number of breakpoints you'll be putting on your DevTools will be much, much lesser. You will have some intuition from your past experience that the problem might be here or the problem might be because of this. So with that intuition, you will go ahead and put a debug point almost near to the place or the context where the real problem will be. That comes with experience. Now let us learn about one more interesting thing is called Workspace. So after page, you will see these arrows. You can click on this and then you'll find something called Workspace. Click on Workspace. That's how you are on the Workspace pane. So what is this Workspace for? You are debugging certain things. You found what is the fix. You're providing the fix in the editor, and the moment you provide the fix in the editor, you want your actual source file in your local hard disk is also get modified accordingly. In the previous example, what we have seen is like we did the changes from here, but after that, I had to go to my source file to the VS Code and I had to do the changes over there, right? But now what I'm saying is like you do the changes from here, but the same change gets reflected on your source file as well. So we have to connect our source project with the DevTools in some way. The way is through Workspace. I have reverted back the fix again. I have brought back this particular plus so that we can again debug and see how we can actually save it on dev.tools and the same thing gets reflected over here. For doing that, I have to add something called a workspace. So I'll go back to DevTools and here I have to add my project folder. So I'll click on add folder and I have selected the source folder. Here you will get a confirmation at the top. DevTools request full access to this particular path. You have to allow this. So I'll allow. The moment you allow, the day 16 that you see on your VS Code, this day 16, inside that index.css file, index.html, all these things will come and sit over here. You can expand and can see all these files. Nice. Now let me open up index.css file. Let me go to this button color. Button color is having a border color which is of this pinkish color, right? Let me change this guy to this teal color. I have changed this to teal color. Now let me save it using Control S. The moment I saved using Control S, you see that this teal color got changed, right? The border color becomes 70dbae for dot button in index.css file. Let me go to the VS Code. Let me go to the index.css. Now for button.btn, you see here also the change has been reflected. I hadn't come here and did the change. I did the change on my DevTools and it's reflecting directly here. Let's do one more thing. We have the bug, isn't it? The bug is if I put some wish, make a wish, I'm getting NaN. I know the fix for this. I have to go to index.js file. I have to just remove this plus. So I have removed this plus. Great. Now it is showing this asterisk here. It means that it is not saved yet. Now I'll press Control S or Command S if you're on Mac. It is now saved. The moment it is saved, of course, this bug has got fixed. If I make a wish, I can see my wish over here. Now, if I go to VS Code and go to index.js file, I'm seeing that the plus sign that I had added before is also gone. So my bug is also fixed. So you can do this amazing thing that you're debugging something on DevTools. You identified the issue, you fixed it. At the same time, it reflects on your code base directly. This is how you can do it. You can attach your source code folder as a workspace into DevTools so that they will be always in sync. I hope you found this one helpful too. You can set up multiple workspaces. If you want one more workspace, you can again do add folder and you can bring another folder in the workspace and can debug and can fix issue and save it directly. So you can go for as many as workspaces as well. With workspace, the reverse is also true. For example, you come over here and going to index.css file, let me again change this color from here. From green, I'm going towards yellow and I have saved it. Now if I go back to my DevTools again, it has already become yellow. You can see over here index.css for the button. This is also reflected the yellow color. So it's both way the sync is possible and is very much working. And here also you can again go back, press your debug point, do the debugging, all these things that whatever you have learned all remains true. At any point in time, if you want to remove it from the workspace, you can do it by right click and remove from workspace. Say remove, this gets removed from the workspace. So now there is no sync between your DevTools changes to your actual local file, actual local source code. Wow, we have come a long way. So we have now covered everything that we had aimed in the beginning of this session. The last two things pending is debugging with VS Code and a few debugging tips at the end. So let's do debugging with VS Code. So everything that we'll be seeing with VS Code is almost similar to any of the DevTools. There might be few options here and there different, but most of the things are exactly same. So let us get started by configuring our code for debugging. Let me open up index.js file, which I am interested in debugging. And if I try to put my mouse in this place before the line number, I see these red dots. These are the ways you can add breakpoint. If I click on it, it will add a breakpoint. You see this red color? It adds a breakpoint. That's called breakpoint. What is breakpoint? You have already learned from the DevTools. But before you add a breakpoint, you have to configure your debugging environment based on what you are debugging on VS Code. For that purpose, you will come to this particular debugging option, which says run and debug. Click on this. Here, if there is no debugging environment configured for you, you will see something called a run and debug. This is what something you need to do to start debugging. So click on this. It will ask you for various options. If you are debugging the unit test, then you will go for debug just test. If you're debugging Node.js application, then Node.js. If you're developing a VS Code extension and you want to debug that from VS Code itself, then VS Code extension. Otherwise, if you are debugging web app, you can select either web app on Chrome or web app on Edge. Okay, so we are running our application on Chrome, right? We have opened it up on localhost 5500. So I'll be going for this web app Chrome option. I'll click on this. The moment I click on this, this is going to open up a launcher for me, which is like a launch.json file which got created inside this .vs code folder. So you will see a launch.json file, which is this file. Now here you have to do few configuration changes. By default, the type is Chrome, great. Request is launch, great. Name you can change as per your own choice. Our application is running locally on 5500. I'm going to change 8080 to 5500. And web root, keep it as a workspace folder as it is. No more changes. Going to this debugging option, you have to click on this particular play button. Let's click on the play button. Once you click on the play button, the VS Code is going to launch that URL you have given, right? Localhost 5500 on a Chrome browser. So this is what is got launched. On localhost 5500, there are multiple projects that are running, but I am interested in the day 16th project. So I'll click on day 16. Now the same wish project got created. You could have given the URL in your launch as localhost 5500 slash day 16 also. In that case, it would have opened the day 16 project directly. But in localhost 5500, you might be running other projects that you will be interested in debugging. That's the reason I've given the URL as only localhost 5500. Excellent. Now I'll go back to the VS Code for a moment again. Now the debug point I'll start putting from this wish, just like before. So I posted a debug point or the breakpoint on this particular line number 4 is called wish. Now going to the app, let me say tapas wish for something. There is no DevTools. I have opened up no DevTools running. I'll click on make a wish. The moment I click on make a wish, you're seeing this particular breakpoint is hit and the program execution has been paused over here. That is where this highlight is showing. Not only that, just like before, at the left side, you are able to see all the scope. You are able to see the local variable name is tapas, right? Mouse over on that also showing. Wish is not going to show you anything because we have not created wish yet, because this particular debug point or the breakpoint is at the line number 4. Now, if I want to go to the next line, here your indicators are there. Just like before, all the indicators are there: step, step in, step out, everything. So you can go one by one. So let us start using the step over, the F10. It will go to the next line. Now you also got wish over here. You can mouse over on the wish to get the thing. Similarly, you can go one by one on all the step. You can go over here, come to logger, then step inside the logger, click on this. You went inside the logger. You want to step out, you came out of the logger. Exactly same thing. You can see the entire call stack from here, just like before. You can right click on it, just like before. You can restart the frame. You can copy the call stack. If there is a console.log, all the console will come to your debug console. So everything that you have done in the DevTools, you are able to do over here. In fact, you can also do even listener breakpoint, just like before on the keyboard, on key up. You can do all these things, right? your all current breakpoints are showing over here. If you want to take out any breakpoints, you can delete it from here, or you can just uncheck so that the breakpoints won't be deleted. It will still remain, but the code execution won't be stopped on that particular line. So please play around with this VS Code way of debugging. For JavaScript on web and the Node.js, it is by default supported. You don't have to really install any other additional extensions, but you have to do that initial configurations what we have done now, and that resides inside VS Code launch.json file. That's the only thing that you have to do. After that, come here and then launch it. Once you're done with the debugging, you can just switch it off using this particular icon click. That's it. You came back to the original form where now the debugging is not running. So I hope setting up VS Code for debugging and utilizing it in the same way that we have seen with DevTools in depth is also going to work here. There are few differences. For example, going from one breakpoint to another breakpoint on DevTools, on most of the DevTools it is F8. In case of VS Code, it is F5. So these are the some tiny differences, but conceptually, it works exactly the same way. Hey, I hope you enjoyed this video, haven't you? Have you learned something new? Let me know with a comment. I want to know like if this video helped you, because whatever I know, most of it about the debugging, about the source panel, I have taught you. There are more things about the network tab. There are more things about the console.log itself that you can learn. You can learn from anywhere. I will also create content related to that in the coming days. Before we end, I want to give you a few tips about debugging that I want you to keep in mind, because debugging right now, whatever you got to know, it's all about the science, right? You have to put a debug point over there. You have to go from here to there. You have to go from this breakpoint to that breakpoint. You have to create a workspace. It's all about the technology and tools. But debugging is also an art. And that art comes from various different factors that I want you to keep in mind. So first and foremost fact is accept. Accept that debugging is like being detective in the crime movie where you are the culprit. Yes. So we are the developers, we are the primary bug creators, and it is perfectly fine to be like that. So you have to accept as a developer that you will be creating bugs. With that, you are also responsible to debug the code and make it bugs free as much as possible. So you have to keep this in mind. So many times people feel or get into the complexity thinking that, oh man, I'm creating too many bugs, too many code churn from me. It's okay. When you're getting started, it happens. But what is more important is gradually you are going to find a pattern in yourself, in your peers, in your team. This particular thing was there before. We had handled it in this way. Look like this is something similar. Probably the similar kind of things would have happened, and I'll try not to make the similar mistake. So first thing is the acceptance that bugs will come, but you have to be responsible to take care of them. Then second is about seeing the bigger picture. Fix for a bug in one component may have a potential to break something else in another component. Hence, you have to have a very clear idea about a bigger picture in some way. It means understand how different components work, how they talk to each other, how different modules work, how do they do data exchange, what are the key factors that you need to understand before you jump into the bug fixes. That's very, very important. A good debugging technique is to take all these things into account before you jump into bug fixes. Don't just jump into debugging. Don't just jump into fixing things. Consider all these aspects also. So seeing the bigger picture is definitely a key thing in terms of doing debugging, a successful debugging. The third thing I'll tell about debugging others code. See, in an organization, most of the cases, more than one people will be working. So it means that there are higher chances that somebody else have written the code and you will be debugging, or someone will be debugging your code, right? So when we talk about improving the debugging skill, it would be much better to polish the skill if you debug the code written by somebody else. It's a real pain to get started with, but this is going to make you a person who can look into code with lot of confidence to find out what's the issue in that. So try debugging others code out of interest, even if it is not told to you. There are a lot of open source projects available on GitHub. There are a lot of projects that you can pick up. You can start debugging their code, start reading their code, try to figure out if there is any improvement that you can bring in. Then the next thing about discussing and looking from different angles. Let's talk about two cases here. Say you have been debugging for a while one issue, but still not found how to fix that. And the second case is you have just found a fix after debugging a code written by your peer or someone. Now, what I have experienced in these cases is discussing the approach with your peer helps accelerating a lot better. Often we get a different ways to look into things. There are different perspective that comes into picture. Your friend, your peer, your colleague would have solved the similar thing in the past. That experience also come into picture. So discussing and looking from other angles can give you a faster way of getting to the issue and fix it. We already spoke about the tool. So making use of the right tools, the right ways. DevTools is a great way. Console.log. Yeah, I told like where it is important, but make sure that you don't rely on console.log alone. Then another tips would be taking a break. This worked like a charm for me. You try debugging for long hours, not reaching anywhere. You try to pull out your hair. And then what happened? 3 a.m. in the morning, you go to bed thinking that, man, what will happen tomorrow morning? I have to submit this one. Morning, once you get up, you immediately find the fix. It happens to many of us. It happens to many of the developers. Taking a break make wonders. Take a good coffee break. Break increases productivity and the creativity. They say that the aha moments come often after taking a good break. So if you're stuck with your debugging, don't really torture yourself by sitting there and trying things. Get up, go out, take a break, get some fresh air, grab some coffee or food, talk to someone you'd like to, come back and start again. There are more chances that you find the issue more quickly. And the last tip, which is the most important tip, I would say, don't give up. Most of the time, debugging is deep. It needs time. It needs energy. It needs patience. It needs attitude. There will be time where you will feel helpless. You will be reaching like, I have reached the end of the tunnel. That's the time for you to come back. See it again from the beginning. Don't give up. You compare the steps between different approaches, different finding, try to find the gaps, try to evaluate it, and then again proceed. Don't give up. I told about the break. There are different methodologies so that it is going to refuel you, but giving up is not the solution. So these are the tips that I want you to keep it with you along with the tooling part. These are the art part of it. And I want you to be successful as a developer. So it's just not about coding. It's also about getting master at debugging. I wish you do really, really well in that. So I'll be back again with another video, and I hope that you like this video. And if so, please post a like, let me know, and don't forget to subscribe to tapaScript. That will be a great support coming from you, and I would really appreciate that. Stay well, keep learning. Thank you.